Photoelectric effect. In photoelectric effect, when a beam of radiation of a particular frequency falls on a metal surface, the electrons are emitted from the surface. This occurs as an effect of absorption of energy by electrons from the incident radiations, which happen to overcome the binding energy of parent metal. Some significant observations regarding photoelectric effect are here, as the photoelectrons are emitted only with a light of certain minimum frequency nu. This is called the threshold frequency, and it varies from metal to metal. Second, the kinetic energy of emitted electrons increases on increasing the frequency of incident light, but remains unaffected on increasing the intensity of light. Third, the number of electrons emitted or photoelectric current produced is directly proportional to the intensity of incident light. The classical theory, however, could not explain these observations. According to classical theory, the energy of ejected electrons is proportional to the intensity and independent of its frequency. Thus, the kinetic energy of photoelectrons should increase with the intensity of light and not with frequency. Secondly, a light of any frequency but sufficient intensity can emit the electrons. But as we know already, the classical theory was contrary to the experimental observations. Einstein used Planck's quantum theory to explain the photoelectric effect. According to Planck's theory, light is made up of discrete packets of energy called photons. Each photon has an energy equal to h times nu. The electron in turn uses this energy to overcome the threshold energy barrier of the metal atoms and to increase its own kinetic energy, that is half mv squared. That is, h times nu is equal to h nu naught plus half of mv squared, where h is Planck's constant and nu is the frequency of light radiation. When this photon of frequency nu hits the electron in a metal surface, it transfers its energy h nu to the electron. We get kinetic energy equal to h nu minus h nu naught, where nu naught is the threshold frequency. The threshold energy h nu naught is also called the work function of a particular metal. If the energy of a photon, that is h nu, is less than that h nu naught, the photon will not have sufficient energy to eject the electron from the metal surface. This equation shows that kinetic energy of electron depends upon the frequency of incident light and not on its intensity. A plot of kinetic energy of photoelectron versus the frequency of incident light gives a straight line with a slope equal to Planck's constant. When the intensity of light is increased, the number of photons striking the metal surface per unit time increases. Thus, more number of electrons will be emitted. However, the kinetic energy of all the electrons will remain unaffected, will be same for a particular frequency. Thank you very much for watching. If you want some more videos like this one, please like, share and subscribe to my channel. Have a great day. Stay home. Stay safe.